The summation sign is a very useful symbol when we work with sums of numbers. Let's say I want to sum these numbers. The sum, of course, is 20. Let's denote the first of these numbers by x subscript 1 and the second of these numbers by x2, x3, x4. The sum of these numbers can then be denoted by x1 plus x2 plus x3 plus x4, which is equal to 20. A more convenient way of writing the sum on the left-hand side is to use the summation symbol. It's the Greek capital sigma symbol. At the bottom, I write I equal to 1 as the sum starts on subscript 1. Then at the top, I write 4 as the subscript ends at 4. After the summation sign, I type xi. And this combination of symbols means exactly the same as the left-hand side, like this. The variable I here is what's called a dummy variable because it makes no difference what name I pick for this variable. Writing, for example, sum alpha goes from 1 to 4 x alpha means exactly the same thing. You can think of this sum simply as a loop where we loop alpha from 1 through 4. Then, in each iteration of the loop, we replace any alpha in the expression following the summation sign, this part here, by the current value of alpha in the loop. For example, summation I go from 1 to 4 xj would not be correct. That would not represent the sum of these numbers. So let's scratch that. In general, we typically use the symbol n if I want to add an arbitrary set of numbers. N is then a positive integer, equal to 4 in the previous example. The general sum of n numbers is then written as sum I go from 1 to n xi, and that can be written as x1 plus x2 plus adding numbers dot 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 all the way until we reach the final number, which is denoted by xn. We can also use the dummy variable inside the expression following the summation sign. For example, if I write summation I go from 1 to 3, and following the summation sign I don't write xi but just I. Think of this as a loop where I goes from 1 to 3. In the first iteration I is 1. In the next step I is 2, so we add that. And in the final step I is 3, and the final sum is 6. Another slightly more complicated example, if I do sum I go from 1 to 3, I square. I starts at 1, so I have 1 squared, then I have 2 squared, and finally 3 squared. So this is 1 plus 4 plus 9, which is 14. A particularly important sum is this one. I sum I from 1 to n. So that's the sum of 1, 2, 3, and so on all the way up to n, where n is an arbitrary positive integer. And the answer is n times n plus 1 divided by 2. For example, summing the first 100 integers is equal to 100 times 101 divided by 2, which is 5050.